This we already proved sum of n minus number in initial classes. So now what we do is, now we will, with the help of this one, we will try to prove this one. What is this? 1 square plus 2 square plus 3 square up to n square is equal to n into n plus 1 to n plus 1 by 6. So to prove that result, what I do is, our result is 1 square plus 2 square plus 3 square plus etc. up to n square is equal to n into n plus 1 into 2n plus 1 by 6. So this is the result. To prove this result, what you do is, consider solution or proof. Consider r cube minus r minus 1 whole cube. So now r cube minus r minus 1 whole cube you consider to prove this one. So now what you do is, so you write this, now you simplify this r cube minus r minus 1 whole cube with the help of a cube minus b cube. So what is a cube minus b cube formula? A cube minus b cube is equal to a minus b into a square plus ab plus b square. Is this true? You use this formula over here. So in place of a, what is there? R. In place of b, r minus 1. So if you use that one, then this r cube minus r minus 1 whole cube is r minus of r minus 1 into r square plus r into r minus 1 plus r minus 1 whole cube. Now this is equals to r minus r plus 1 into r square plus r square minus r. This is a minus b whole square, r square plus 1 minus 2r. Now minus r plus r cancel. So this is just 1 only. Now here r square, r square, r square. That is in bracket 3r square minus r minus 2r minus 3r plus 1. So what we have, that is what we got, r cube minus r minus 1 whole cube is equal to this one. That is 3r square minus 3r plus 1. So now what you do is, here, so okay. Now this is equal to 3r square minus 3r plus 1. Now give this to number 1. Now in this first one, you put r is equals to 1, 2, 3, etc. up to n. If you put r is equal to 1, then 1 becomes what? 1 cube minus 0 cube is equal to 3 into 1 square minus 3 into 1 plus 1. Now if you put r is equal to 2, 2 cube minus 1 cube is equal to 3 into 2 square minus 3 into 2 plus 1. If you put r is equal to 3, 3 cube minus 2 cube is equal to 3 into, so 3 square minus 3 into 3 plus 1, etc. etc. If you put r is equal to n, then what we get? N cube minus n minus 1 whole cube is equal to 3 into n square minus 3 into n plus 1. So next what you do is, now add all these equations. So if you add, then what you get? If you add left hand side terms, if you add, then you will have like this. That is 1 cube minus 0 cube, first term. Second term is what? 2 cube minus 1 cube. 2 cube minus 1 cube plus 3 cube minus 2 cube plus etc. up to n cube minus n minus 1 whole cube. This is left hand side. Now if you write if you add right hand side, then you add like this. In right hand side, you add these terms. First, if you add these terms, then what you get, 3 take out common. 3 into 1 square plus 2 square plus 3 square up to n square. So this is 3 into 1 square plus 2 square etc. up to n square minus. Now second terms, if you add, minus 3 take out common. 3 into 1 plus 2 plus 3 etc. up to n. Minus 3 into 1 plus 2 plus 3 plus etc. up to n. Next, last one is add all the ones. 1 plus 1 plus 1 plus 1. How many times? N times. Therefore, n. 1 plus 1 plus 1, n times is what? N. Now, if you observe this left hand side, so in left hand side, this 0, this is anyway 0. Minus 1 cube plus 1 plus 1 cube cancel. That is 1, 1 cancel. Next, this 2 cube cancel with this 2 cube. Like this, every term will be cancelled except this n cube. N minus 1 whole cube cancel with the preceding term. So in preceding term, you will have n minus 1 whole cube. Therefore, this cancel with this n minus 1 whole cube. Just you left with what? N cube. So now this is equal to left hand side, you left with n is equal to this 3 into. So this is our requirement. That is 1 square plus 2 square plus 3 square etc. This is our requirement. Minus 3 into, this is sum of n natural numbers. 1 plus 2 plus 3 etc. So that is n into n plus 1 by 2 plus n as it is. So our requirement is what? This one, 1 square plus 2 square plus 3 square etc. Sum of the squares of n natural numbers. So to get our requirement is this one. So isolate this one. So for that one, you take out this term and this term left hand side. Otherwise, oh, this is left hand side is n cube actually. It's not n cube. So now you take out these two terms left hand side. Then what you get? This 3 into 1 square plus 2 square plus etc. up to n square is equal to n cube plus 3 into n plus 1 by 2 minus n. So this is equal to, here 2 is LCM. This is 2n cube plus 3n square plus 3n minus 2n. Sorry. Minus 2n. This is what? 3 into 1 square plus 2 square etc. up to n square. Now this is equal to 2n cube plus 3n square plus n by 2. So now this implies this is 3 into 1 square plus 2 square etc. up to n square. But our requirement is what? 1 square plus 2 square etc. 1 square plus 2 square etc. up to n square is equal to 2n cube. From numerator n take out common. If take out n common, 2n square plus 3n plus 1 by 6. Now this is equals to n into, you factorize the back inside the bracket term. That is 2n square. You can write 2n as 2n plus n plus 1 by 6. So which is equals to n into, from these two terms you take out 2n common, 2n into n plus 1 plus n plus 1 by 6. Next n into, from these two terms again n plus 1 common, n plus 1, then we left with n 2n plus 1 next. N into n plus 1, 2n plus 1 by 6. So this, therefore 1 square plus 2 square etc. up to n square is n into n plus 1, 2n plus 1 by 6. This is the proof. This is the sum of the squares of n natural numbers. So with the help of this one, we can prove the sum of the cubes of n natural numbers also. Suppose the question is 1 cube plus 2 cube plus 3 cube etc. up to n cube then this is equal to what? N square into n plus 1 whole square by 4. To prove this one, you consider r power 4 minus r minus 1 power 4 is equal to, you expand this one, you write like this previous one, then same procedure, put r is equal to 1, 2, 3 and 2. So this is the general method. The proof is not required, nobody will ask you. Final result is important, but it's better to learn the proofs. The thinking will be developed.